Hello, my name is Anay Ravelo, and I'm a PhD student in the College of Veterinary Medicine at the University of Minnesota. And for this presentation, we will consider comparisons of the ruminal microbiome and metabolites of low and high-producing dairy cows. Dairy product consumption in the U.S. has maintained constant or increased throughout the previous years, and this includes products that we may consume on an everyday basis, such as cheese, milk, yogurt, ice cream, condensed milk, and whey. All of these products come from milk production in dairy cows, and thus in order to meet demand while also maintaining environmental sustainability, dairy farmers and research scientists are constantly considering ways to help increase milk production in dairy cows. Dairy cows are a ruminant species, which means they have one stomach composed of 4 compartments. These compartments include the rumen, reticulum, omasum, and abomasum. The rumen of dairy cows houses microbes that ferment the feed that the cows consumes into end products, and thus the rumen is considered to be a large fermentation vat. This fermentation vat allows ruminants the advantage of being able to turn low-quality feed into favorable end products that can be used as protein and energy sources for the animal. The way that this occurs is that microbes will take feed substrates that enter the rumen and through fermentation create end products such as microbial crude protein and short-chain fatty acids that can either be absorbed through the rumen wall or can move further along the digestive system and be later absorbed by the animal. And thus we're able to describe what is the rumen microbiome. The rumen microbiome will be the collection of all microbes such as bacteria, fungi, viruses, naturally live in the rumen. We're also able to define what is the rumen metabolome. The rumen metabolome will be the collection of all molecules such as short-chain fatty acids and amino acids that are found in the ruminal fluid. Thus, the purpose of this study was to consider associations between the rumen microbiome and metabolome in relation to low versus high producing dairy cows. In order to conduct this study, we paired 12 high producing dairy cows to 12 low producing dairy cows based on their genotype. These cows were matched based on their lactation, sire, and health events. And we collected rumen fluid from these cows using a rumen gastric tube, which allows us access to the cow's rumen as an uninvasive method in order to collect the rumen fluid. We also collected blood samples from these cows through their tail veins into serum tubes. After analysis of these samples, it was observed that there was no difference in the microbial populations present in the different rumen fluids, which means there was not a difference in the microbial populations present or in the abundance of microbes present. We also did not observe a difference in the concentration of rumen metabolites present in the rumen fluids. However, we did observe that there was a positive association between milk production and the concentration of metabolites in the serum. This observation was not observed when comparing milk production to the concentration of metabolites in the rumen fluid, which can be indicatory that post-digestive processes may have a greater association with milk production than processes and functions occurring in the rumen. Thus, moving forward, we may want to consider these post-digestive processes and functions and their relationship to milk production. With that, I would like to acknowledge the help of my advisor as well as everyone that helped in this project. And if you have any questions, I'd be happy to address them. Thank you.